Welcome to this comprehensive guide on Istio Telemetry and Observability. In this video, we will explore how Istio provides powerful observability features through metrics, traces, and logs. Understanding telemetry is crucial for monitoring, troubleshooting, and optimizing your microservices running in a service mesh. Istio automatically generates detailed telemetry data for all service communications, giving you deep insights into your application behavior without requiring any code changes. Let's dive into the 3 pillars of observability and learn how Istio makes monitoring distributed systems easier than ever. Observability in distributed systems relies on 3 fundamental pillars. First, we have metrics, which are numerical measurements of system behavior over time. Metrics help you understand trends, detect anomalies, and measure performance indicators like request rates and latencies. Second, traces provide visibility into request flow tracking across distributed services. They help you understand how a single request travels through multiple microservices and where bottlenecks occur. Third, logs are detailed event records from service operations. They capture specific information about individual requests, errors, and system events. Together, these 3 pillars give you complete visibility into your service mesh, enabling effective troubleshooting and performance optimization. Istio provides comprehensive metrics across multiple layers of your service mesh. Service-level metrics include request rate and volume, request duration and latency, and request success or failure rates. These metrics help you understand how your services are performing from an application perspective. Proxy-level metrics give you insights into connection pool statistics, circuit breaker status, and Envoy proxy performance. These are crucial for understanding the health of your mesh infrastructure. Control plane metrics track components like pilot configuration synchronization, Citadel certificate operations, and Galley validation status. All metrics are automatically generated in Prometheus format with standard metric dimensions, and collection is enabled by default without requiring any manual configuration. Istio exposes several standard metrics that you can use to monitor your services. The Istio_requests_total metric tracks the total number of requests handled by your services. The Istio_request_duration_milliseconds metric provides the request latency distribution, helping you identify slow requests. The Istio_request_bytes metric shows the distribution of request payload sizes, while Istio_response_bytes tracks response payload sizes. For TCP traffic, the Istio_TCP_connections_opened_total metric counts the total number of TCP connections opened. These metrics are automatically collected from Envoy proxies and can be scraped by Prometheus for analysis and visualization. Distributed tracing is essential for understanding how requests flow through your microservices architecture. Istio enables distributed tracing by leveraging Envoy proxies to track request flow across multiple services in the mesh. The key features include trace context propagation, where headers are automatically forwarded between services to maintain trace continuity. Envoy proxies generate spans for each request, capturing timing information and service interactions. You can configure trace sampling rates to control the overhead on your system, allowing you to balance observability needs with performance requirements. Istio supports integration with popular tracing backends, including Jaeger, Zipkin, and OpenTelemetry, making it easy to visualize and analyze traces using your preferred tools. For distributed tracing to work correctly, applications must propagate specific trace headers when making requests to other services. The X-request-id header uniquely identifies each request across the entire trace. The X-b3-traced header contains the overall trace identifier that groups all spans belonging to a single request. The X-b3-spanned header identifies the current span within the trace. The X-b3-parent-spanned header links the current span to its parent span, establishing the hierarchy. Finally, the X-b3-sampled header indicates whether this trace should be sampled and recorded. While Envoy proxies automatically generate and propagate these headers between proxies, your application code must forward these headers when making outbound requests to other services to maintain the complete trace chain. Access logs provide detailed records of all requests passing through Envoy proxies in your service mesh. These logs are invaluable for debugging, auditing, and understanding traffic patterns. Access logs capture comprehensive information including request and response details such as HTTP methods, paths, and status codes. They record source and destination information, showing which services are communicating with each other. Timestamps and latency measurements help you identify slow requests and performance issues. HTTP status codes reveal errors and failures in your system. User agent strings provide information about clients making requests. Additionally, Istio supports custom log formats, allowing you to tailor the logging output to your specific needs and integrate with your existing logging infrastructure. Enabling access logs in Istio is straightforward through configuration. You can configure access logging during Istio installation or by updating the mesh configuration afterward. The configuration uses the Istio operator custom resource with API version install.istio.io/v1alpha1. Under the spec section, you define mesh config parameters. Set access log file to /dev/stdout to send logs to standard output, making them available through your container logging infrastructure. You can also set access log encoding to JSON for structured logging, which makes it easier to parse and analyze logs with tools like Elasticsearch or Splunk. This simple configuration enables comprehensive access logging across all services in your mesh without requiring any changes to your application code. The Istio Telemetry API provides fine-grained control over telemetry generation in your service mesh. This modern API offers several powerful capabilities. Selective configuration allows you to control telemetry settings per workload or namespace, giving you flexibility to optimize observability for different parts of your application. You can define and export custom metric dimensions to track business-specific data points that matter to your organization. Log customization enables you to tailor access log format and choose which providers receive your logs. Performance tuning features help you optimize telemetry overhead by adjusting sampling rates, filtering unnecessary data, and controlling export frequency. The Telemetry API replaces older mesh config-based telemetry configuration and provides a more flexible, scalable approach to managing observability in large service meshes. Istio integrates seamlessly with popular observability tools to provide a complete monitoring solution. For metrics collection and storage, Prometheus is the standard choice, scraping metrics from Envoy proxies and storing time series data. Grafana provides powerful visualization capabilities, allowing you to create dashboards that display metrics and identify trends. For distributed tracing, Jaeger is a popular backend that collects and analyzes distributed traces, helping you understand request flows and identify bottlenecks. Zipkin is an alternative tracing backend that also integrates well with Istio. Kylie offers specialized service mesh visualization, showing topology and health of your mesh services. For log aggregation and forwarding, Fluentd collects logs from all your services and forwards them to centralized logging systems. Together, these tools form a comprehensive observability stack that gives you complete visibility into your service mesh. Let's recap the key points about Istio telemetry and observability. First, Istio provides automatic telemetry generation for metrics, traces, and logs without requiring changes to your application code. Second, Envoy proxies are the workhorses that generate telemetry data at the sidecar level, capturing all traffic flowing through your services. Third, applications must propagate trace headers when making requests to other services to maintain complete distributed traces across the mesh. Fourth, the Telemetry API provides fine-grained control over observability, allowing you to customize telemetry generation for specific workloads and optimize performance. Finally, Istio integrates seamlessly with standard observability tools like Prometheus, Jaeger, and Grafana, making it easy to visualize and analyze telemetry data using familiar interfaces. Thank you for watching this guide on Istio Telemetry and Observability. You now understand the 3 pillars of observability, how Istio automatically generates metrics, traces, and logs, and how to integrate with popular monitoring tools. With this knowledge, you can effectively monitor, troubleshoot, and optimize your microservices running in an Istio service mesh. Observability is crucial for maintaining reliable distributed systems, and Istio makes it easier than ever. Keep exploring the Kubernetes Service Mesh series for more in-depth topics. Happy monitoring!
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.